Dear student, welcome to Gsquare Maths. Today we are going to start a new branch of mathematics, one of the very important branch in mathematics, which is used by all scientists. It is true that without calculus there is no research part at all. Each and every research, even including geography, history, any subject if you take, the research will be incomplete if there is no calculus part in that. So such a vital topic we are going to take today. Before entering into the kingdom of mathematics, this mathematical calculus, we would like to cross some 2-3 more steps. So far the mathematical knowledge, so far we acquired right from first standard, we are going to apply that in calculus. That is the reason, of course, we studied so far for this usage. Then before entering into that kingdom, we have to cross 3 more steps. Let me start with a very small narrations. There are 3 railway stations. You can call it as name A, B, C. I am standing in this. There are 3 railway stations. A, B is a city, C is a city, A is another city in which I am there, of course. In the city railway station I came, and once I want to go somewhere else, either the B city or C city, I am just standing on the platform of the station A. Somebody is running, and my old student, he rushed and came to me, "Sir, train is approaching the station." What we can infer from this statement? The statement is very clear and simple. "Sir, the train is approaching the station. I am standing here." 3 things we can conclude from this statement. One is, I don't know from which direction the trains are coming, whether it is coming from the B station or it is coming from C station. Another thing is, the train has not stopped in the station A. It has not. Otherwise, the statement is it's approaching. Approaching, either it is coming from this side or it is coming from this side. It is just approaching this. Still, it has not come and halted at the station A. If the train would have stopped at the station A, he would have given the station, "Sir, train is in the station." But train is not there in the station, it is approaching the station. So, that the third thing what we can infer from this, the distance between the train and the station is coming to 0, tends to 0. So, approaching, and the distance between the train and the station where I am standing is approaching to 0. So, the concept is very important. The object which is approaching at a particular point. Another one small example I would like to give. Just I am dropping an object. I am standing on the top of the hill. I am just dropping an object. Let the distance covered by the object at the particular point of time is 4.9 t square. We know how the equation comes. Equation of motions we know. The basic students, you may be knowing that. You are mathematics students also. S is equal to ut plus half a t square. When I am dropping the object from A, the initial velocity u is equal to 0. Therefore, S is equal to half gt. G is a gravitational force. So, half into gt is 4.9. G is 9.8. So, it is half into gt. So, this is equation of motion that the object is coming down. Now, in the first second, the object is covered this much of distance. The second, the object is covered this from here to here. The third second, the object is coming from here to here, like the go on, it's like that, till it reaches the ground. Somebody asking me, with this equation of motion, can you find this velocity of the object when the time is equal to 2 seconds? Now the question is how to calculate the velocity of the object. We know that the velocity is nothing but the rate of change of displacement. Distance covered by the object divided by the time. Now let us calculate the average speed of the object. Now this is what the calculus is. This is what the calculus is going to do. That is very, very important. The scientist is looking for this type of objects, things only this, because the objects are moving in the space. At a particular time, the scientists want to know what is the speed of the object. They know only the equation of motions. Nobody is there inside. And from the equation of motions, how to calculate this velocity, how to put the object or satellite in another orbit. They need this velocity of the object. So when the object, when they want to know the speed of the object, this type of things is very, very important to understand the concept. Here I am dropping this object. Of course, I can find the average speed. Average speed is nothing but the distance traveled in a particular time divided by number of time. See, suppose the average speed in second, that is from here to here. I can calculate the distance covered by the object. I can calculate the distance covered by this by using this. Substitute t is equal to 1, you will get the distance. Substitute t is equal to 2, you will get this distance from here to here. Subtract that, you will get this one. So that divided by 2 minus 1 time taken. So you will get the speed. So the velocity is equal to distance at t is equal to 2 minus distance at t is equal to 1 divided by time. Time lapse 2 minus 1. So this distance will be getting, for example, 10 kilometers. Then this is 1 hour. So we can say the average velocity of the object is 10 by 1, that is 10 kilometers per hour or seconds or minutes, whatever it may be. So you will get the speed. Now this is only the average speed. But here the question is, I want the speed of the object at a particular time. What is the speed of the object at the when time is equal to 2? Exactly 2. So then exactly 2, if I want to see that, it is calculate for 1.5 and for 1.75, 1.9. Now see here, when I am coming closer to 2, the average speed between 1.9 and 2, the distance covered by this divided by 2 minus 1.9, that is 0.1. So the distance covered we can easily calculate, substitute that in this t is equal to 2 and t is equal to 1 minus 9, you will get it from the distance covered. So this distance covered from that you will get. So again, when we are calculating this time lapse is 1 second. 1 second, one fraction of, very fraction of a second is also very much big for the scientist. We don't know where the object will move, which direction object will go. Object may blast also in between 1.9 and 2. So still we are calculating the average speed only. The actual speed, the instantaneous speed at time t is equal to 2, still we have not come to. Okay, let us approach. This is at 1.9 and this is 2. Come still closer, 1.99. Here the time taken here in between this is 0.01. Even still we can say that the average speed only it is. Yes, time lapse is 0.01. So that distance also I got to avoid. So still the object is coming closer, 1.999. Still the time lapse is 0.001. So distance covered by this we can calculate easily. Total distance for 2 minutes, total distance by 1.999. So we get the distance. That distance divided by 0.001. So but still it is an average speed in the last fraction of seconds. But it is not exactly the speed at the point 2. But we are interested to exactly want to know what is the speed at the particular point t. So to find out this particular velocity at this point, I am taking time t tends to something. This is a time, this is a speed. 1.5, 1.9, 1.999, 1.999 for example. You calculate this, something you are getting this. Some value you are getting. So now this is, I am coming from that other side. Now the point is approaching from, the time is approaching from here. 2, 3, 2.5, 2.1, 2.01. That time I am coming from back side. The time is coming from this side. The time is approaching a point 2. We already studied what it is approaching. The train is approaching the station. The train tends to the station A. The distance between the train and the station is narrowing, coming to 0. So like that, the time is coming towards 2. Then the speed of the object may be L. Here this time is approaching to 2. So that concept is a limit concept, limit of the distance, speed of the vehicle when t is equal to 2 is L. So we can write this as limit as t tends to 2 of the function is equal to L. L is the limit of the given functions. So let us take the second example. An object is moving with an equation . Distance covered by the object is given by an equation of t. S is equal to f of t. Now let us calculate what is the speed of this object when t is equal to 2. So what I have to do that, I have to substitute t is equal to 2. If I substitute t is equal to 2, the speed of the velocity object is coming as 4 minus 4 by 2 minus 2, which is coming as 0 by 0, which is an indeterminate form. That means the speed, somewhere the object has lost in the space or where it has gone. You are not able to find the speed. But the speed after that also is moving. Why? Because when t is equal to 3, we are getting. As t is equal to 3, that means 5. The velocity of the object is coming 5. When t is equal to 4, it is coming, object is coming as 6. Velocity is 6. When t is equal to 5, the velocity is 7. Like that it is coming. How it is very simple. It's not a very big calculation in this. This can be written as t plus 2 into t minus 2 by t minus 2. I can cancel this. I can cancel provided t not equal to 2. When t is equal to 2, I cannot cancel this. Why? Because when t is equal to 2, it is 0 and 0. 0 and 0 cannot be cancelled. If that is the thing, 5 into 0 is 0, divided by 0, the 0, 0 cancel, it is equal to 5. Big question mark. We are coming to a contradiction in mathematics. So, I cannot cancel it. But when I can cancel if t not equal to 2. So, let me take all other values. T is equal to. When t is equal to 1, it is 1 plus 2, it is 3. When t is equal to 1.5, it is 3.5. That's what I calculated. It is going like this. When 1.9, it is 3.9. 1.99, it is 3.9999. So, as t is approaching the number, this is 2. This is when t is equal to 2. So the question is, when t is equal to 2, what is the speed of this object from this equations? That's what we are calculating. As t approaches to t, the value is tending to somewhere else. 3, 3.5, 3.9, 3.99. Next, if the time is 1.9999, the velocity is 3.9999 like it goes. Similarly, we are coming from this side. It is 5, it is 4.5, it is 4.1, it is 4.01, and we are coming closer. Here, the speed of the object is approaching to some value when it is coming this point. Similarly, this is also reducing, and it is approaching some point. The train approaches the station. The distance between the station and the train is almost is going to be 0. Then I can say that the train is in the station. Similarly, if it is approaching something, when t is equal to 2, we cannot find the value, exact value. But one thing I can say that it tends to some value. That value is we used to define as a limit value. That always would affect a given function. Let x is equal to c. This is a given point. When from the left side, from the right side, we are calculating like this, and it is coming to a point L. When c minus, here c plus. When from this it is coming towards this point x equal to c, and from here it is x equal to c, it is coming. We are coming to a number which is both sides approaching, from the left side as well as from the right side. And it is almost, it is coming. By seeing that, it is coming closer to a particular value. That value only we used to call as a limit value. In this case, the limit value, the limit extends to 2 minus. This is a symbolic representation for the left hand limit. Time is 2 minus. Anything minus. It may be 2 minus 0.000000001. How many zeros you put? So that much closer you will come to this 2. That the function s f of t is equal to, that value is something. Some value is coming is 4. Similarly, from the right side also I am approaching, the right hand limit x tends to 2 plus. That for the right hand limit, we used to call it the 2 plus. 2 plus means 2.0000001, then 2.00001, then 2.5, 2.753. So like that it goes. So then this tends to 4, this f of t x is equal to, again it is tending to 4. This also tends to 4, this also tends to 4, tends to 4. Both when t is equal to 2 is almost coming to a point t is equal to 4. The function value is equal to 4, and that we used to call it as a limit value. Therefore, here limit x tends to c of fx is equal to L. This L is known as the limit value of the given function at the point x equal to c. So, when that value will be L, if the left hand limit and right hand limit is tending to a particular value. Sometime we will come to see some examples. At that time it may be very clear to you. Left hand limit cannot be equal to right hand limit. Left hand limit may be equal to right hand limit. Left hand limit equal to right hand limit, but it is not the functional value. What is the functional value? In a given function, substitute x is equal to that particular value, that is known as the functional value. So, for example, here, if I am substituting, this is f of t. I am substituting f of 5. I can put directly t is equal to 5. There is no ambiguity comes. There is no indeterminate form comes. This is not coming to 0 by 0. This is coming 0 by 0 only if t is equal to 2. So if t is equal to 5, what is the substitute the value t is equal to 5? That's the functional value. Functional values are those values of a given function if you the variable x or t or whatever it may be substituted by the given value. That's called the functional value. But this is not the functional value. This is limit value. It is tending to this. Dear children, so let us define what is limit of a given function at a given point. We have seen just an example. F of t is equal to t square minus 4 by t minus 2. This is not defined by t is equal to 2. We have seen that limit value, right hand limit, left hand limit. Also, they are equal and it is coming to the value 4. We also see what is the functional value. Here the functional value of t is equal to 2 is not existing. So how we are going to define? Functional value has no concern with about the limit. When you are talking about the limit, there is no problem of functional value. Functional value may be equal or may not be equal. So we will define the limit like this. If the left hand limit, that is limit x tends to a minus fx, and right hand limit x tends to a plus. If these two are equal, this may be equal, they may not be equal also. If they are equal, we can say that left hand limit is equal to right hand limit. In that case, we can define the function is existing, the limit value existing at the point x equal to a. So let us not confuse with the functional value. Functional value will not come in the picture at all. We are not concerned about the functional value also. So in this case, therefore, LHL is equal to RHL is equal to yes, therefore limit exists. So let us see some example also. Let fx is equal to, for all x is positive and equal to 0, 2 for all x is negative. This function is like this. For all x is positive, it is 1. 0 is included. 1 is included in that. So this is y is equal to 1. For all x is positive and equal to 0. So 0 is also included value. And for negative values, it is 2. It is not included. Y is equal to 2. So let us see that what is left hand limit. Left hand limit, that is limit x tends to 0 minus. 0 minus the function value is equal to 2. Whereas the right hand limit, when x is approaching the point 0 from this to this, like this, it is approaching here, the function value is 2 only. Even closest to 0 also the function value is this. And limit x tends to 0 plus of fx, here x is approaching 0 from right side. Coming closer to 0, the value is 1. Left hand limit not equal to right hand limit. Therefore, limit does not exist. See, my dear children, here at the point x equal to 0, the functional value is defined. The functional value is defined and that is equal to 1. Right hand limit is also 1. Functional value is also 1. Left hand limit is 2. But as left hand limit not equal to right hand limit, the function is not defined. So let us take another example. The function which we know already, this we used to call it as a modulus functions. The graph of the given this function will come like this. Y is equal to x and y is equal to minus x. Positive x-axis, negative x-axis, y-axis. So for all 0 and positive values of this, the function is y is equal to x, and for this it's y is equal to minus x. So let us check the left hand limit. Limit x tends to 0 minus of fx. So limit x tends to, at the left side of 0, the function is minus x. That is equal to minus of 0, that is 0. Let's check the right hand limit. Limit as x tends to 0 plus of fx. That is equal to limit x tends to 0 plus of x. At the right side, the function is defined as x. So that is equal to 0. Therefore, left hand limit is equal to right hand limit, and hence fx is differentiable and x is equal to 0. Fx is limit exists. Hence, for fx, limit exists at x is equal to 0. So let us take the second example. One more example. Let y is equal to x square plus x. We have to discuss the limit value at x is equal to 2. For example. So as it is a quadratic function, it's a parabola it is. And this is the upward parabola. Why? Because the coefficient of x square is positive. And moreover, 0 of this polynomial is minus 1 and 0. And hence, the graph of the function comes like this. So let us take at the point x is equal to 2. At the point x is equal to 2, at the left side and right side the function is same. At the left side and right side the function is defined as same. The function is x square plus x, and this side also x square plus 1 x. Now the question is, at x is equal to 2, we have to find out the limit value of this. So let us take x approaches 2. So coming close in this, at this point, the value is like this. So in this case, of course, y is equal to 6. The limit value will also 6 and the final function value is also 6. At the right side of this, maybe slightly more than 6 and slightly more than less than 6, but this approaches here to a 6 and this also approaches to a 6. And hence, left hand limit is equal to limit x tends to 2 minus function is x square plus x only. That is 2 whole square plus 2, that is 6. The right hand limit is limit x tends to 2 plus. For that also the function is same, so it is x square plus x. So that is again 6. Therefore, LHL is equal to RHL. No need of telling that the function value is what? To discuss about the limit of a function at a particular point x equal to a, in this case x equal to 2, it is not be mentioning the functional value of that function at that point. Let us wind up this today. The future, we are going to give an assignments. The assignment will be loaded in the website. You can see that.